Hello students, today we begin an important chapter from three-dimensional geometry, equations of planes and spheres. In this first part, we'll understand what a plane is, how to write its different forms of equations, and how to find the angle between two planes. Let's start. A plane is simply a flat surface that extends infinitely in every direction within three-dimensional space. You can imagine the floor, a wall, or even the surface of water as examples of planes. If a line is perpendicular to a plane, then every line parallel to that line will also be perpendicular to the same plane. General equation of a plane. The general equation of a plane is written as ax plus by plus cz plus d equals 0. Here, the letters a, b, c are called the direction ratios of the normal to the plane. The letters x, y, z represent any point lying on the plane, and d is a constant term that fixes the plane's position in space. Plane passing through a given point. If a plane passes through a point having coordinates x1, y1, z1, and it is perpendicular to a vector whose direction ratios are a, b, and c, then its equation is a multiplied by open bracket x minus x1 close bracket plus b multiplied by open bracket y minus y1 close bracket plus c multiplied by open bracket z minus z1 close bracket equals 0. Example, find the equation of a plane passing through the point 1, 2, 3 and perpendicular to the vector 2, 3, minus 1. Substituting these values, we get 2 multiplied by open bracket x minus 1 close bracket plus 3 multiplied by open bracket y minus 2 close bracket minus open bracket z minus 3 close bracket equals 0. When you simplify it, you get 2x plus 3y minus z equals 7. That is the required plane equation. Other useful forms. There are two other useful forms of plane equations. 1. Intercept form, x divided by a plus y divided by b plus z divided by c equals 1. Here a, b, and c are the intercepts that the plane makes on the x, y, and z axis. 2. Normal form, lx plus my plus nz equals p, where the sum of the squares of l, m, and n is equal to 1. These letters L, M, N are the direction cosines of the normal to the plane, and P is the perpendicular distance of the plane from the origin. Plane passing through three non-collinear points when 3 points are known, say x1, y1, z1, x2, y2, z2, and x3, y3, z3, we can write the equation of the plane in determinant form. It looks like this. The determinant formed by the three rows x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, and x3 minus x1, y3 minus y1, z3 minus z1 is equal to 0. This ensures all 3 points lie on the same plane. Angle between two planes. If the two planes are a, 1x plus b 1y plus c 1z plus d1 equals 0 and a, 2x plus b 2y plus c 2z plus d2 equals 0, then the angle between them, called theta, is given by cos theta equals open bracket a, 1 multiplied by a 2 plus b 1 multiplied by b2 plus c1 multiplied by c2 close bracket divided by the product of the square root of open bracket a 1 square plus b 1 square plus c1 square close bracket and the square root of open bracket a 2 square plus b2 square plus c2 square close bracket. If the value of cos theta is 0, the planes are perpendicular. If the ratios a 1 by a2, b1 by b2 and c1 by c2 are equal, the planes are parallel. Example, find the angle between the planes 2x plus y plus 2z equals 5 and x minus y plus 2z equals 3. Here, A. 1b 1c 1r2 1 and 2. A to b to c 2r1 minus 1 and 2. So cos theta equals open bracket 2 into 1 plus 1 into minus 1 plus 2 into 2 close bracket divided by square root of 9 multiplied by square root of 6. That gives 4 divided by 3 into root 6. Hence theta equals cos inverse of open bracket 4 divided by 3 root 6 close bracket. Conclusion. So students, in this part we have learned the meaning of a plane, its general and special forms, and the formula for the angle between two planes. In the next part, we'll explore the angle between a line and a plane, the distance from a point to a plane, and finally the equation of a sphere. Let's move to part 2. Jai Hind.